and subtraction formula. And let me give you a little introduction. This is a very, very fundamental result. It gives you the foundation of the geometry of complex numbers. Complex numbers are with the imaginary numbers. With that, and this Fourier analysis is developed. I posted this video in the study group about Fourier analysis, the machine and all the beautiful thing. So you will see in this course the application of addition and subtraction formula to the Fourier analysis. I'm going to show you some demonstration of this Fourier analysis. There's the main application of addition and subtraction formula in this course is this Fourier analysis. It's a really fantastic application. But where it sits in terms of a science and mathematics, this becomes a backbone of, the fundamental result of a modern language of science, things like that. So anything that, the physics about anything that vibrates, and behind it there is this mathematical foundation called addition subtraction formulas. All right. So I'm going to ask you to memorize that. You might forget this after the semester, but I think it's rather than just giving you the formula sheet and just doing that, I really want you to memorize this formula. So in the test, there'll be a problem like state this addition and subtraction formula, and you state it correctly, and then a different part, use that formula to do this and that problem and things like that. All right? So you'll be asked to state the formula from memory. All right. So I'm going to show you some animation. What are you going to do with this formula? And here it's already there. This is our first curve. You can see this is not actual motion, right? This is a space-time. This is a space, one-dimensional space, and time was extended like this. But the motion is actually this one in here. Suppose I pluck a string that creates a motion, that the energy is propagated through this air that filled in that space that vibrates the air molecule like that, right? So this is actually air molecule. Is energy is coming from string out there. So it died out, and then I have another set of string there. I plug that one. That's a little louder, but it is also lower frequency. I hope you can see that from this two animation. All right. So I understood. These two different forces created two different forces. But here's an air molecule, the same thing. If I hit this both string at the same time, then one force is creating this motion, and the other force is creating different shorter motion like this one. And what could happen to the air molecule? One thing is pushing it like that with a smaller frequency, and another thing is pushing with a larger amplitude and larger frequency like that. What's going to happen to this air molecule if the combined forces are acting on that? So this is what happened. So the molecule, if you combine them together, the air molecule moves like that. It's different from usual sine and cosine move, right? See doing the funny thing in between right there, and does funny thing and then go back and forth, right? If you look at the graph, there's no chance that it's going to be sine and cosine. So this one travel through and go to your ear and vibrates your eardrum in this fashion, just like that, as you see. And it goes to brain, and if you're musically trained, then it's actually, this is how my ear vibrates, but I can see that it actually came from this frequency and that frequency. So these two notes I actually play together, and I can kind of see that some trained people can do that, right? By listening to some chords, the piano chords, they can spell out, oh, that involves this and this and that, right? So some people can figure out by listening, receiving that one, they figure out, oh, it's this one and that one mixed together, right? This is called frequency decomposition. If a light is coming into the earth, and then you can put it into a prism, and it decomposes the frequency. How much of this red light part is involved in there, how much of the blue part is involved in there. That's exactly the same thing. Certain wave is coming in, and you decompose into that. That mathematical process of doing that mathematically is called Fourier analysis, right? Seems like an important thing. By observing something, you can decompose its analysis. From there, you can see, oh, that star we're observing, it's made out of this type of gas and around the surface, and all that come from this analysis, right? So what we're going to learn in this course is mathematical way of doing that. And in general, it's very, very difficult calculation, but we're going to focus on an example that's fallen into the realm where we can use this addition and subtraction formula. And here is some, complicated mixture of algebra, sine and cosine, and then boom, you can just decompose it into this much of amplitude of this frequency in here, and this much of amplitude, that much of frequency, all together creates this whole thing. You can decompose it. Good? That's what we're going to do, one of the main application. All right, so what is it? This formula looks a lot more complicated than anything that you have seen. So rather than just giving it to you, I'd like to explain it a little bit. And this explanation, I find it is the fastest way of explaining, but it requires a little bit of matrix algebra. So if you don't know matrix algebra, it might not make sense too much, but I'm going to explain everything here. And I find it is more insightful, enlightening than usual proof kind of the thing. All right? So let me explain what this thing is about. Before I explain, this formula is about angles. So you can imagine, you can easily sketch, if I give you an angle S and T, you can easily sketch S plus T, right? And you can easily sketch S minus T. But if you hit that one with a cosine of S plus T, parenthesis S plus T, cosine of S minus T, how is this related with cosine S and cosine T? That's what the formula is about. So cosine and sine values of angle S and T and angle S plus T. That's what this formula is about. How I'm going to relate that is this idea. It's a fairly fancy idea. So linearity is a certain property that means if you have just this information, you can predict everything. So one way to summarize the phenomenon of linearity in mathematics. If you have this two information, you can predict everything. Okay? So the goal is that you're rotating the point by theta degrees. So let me show you that problem in this picture. So here's x, y coordinate, and x coordinate. Here's a rotation problem. I'm looking at this point 1, 2. Doesn't quite look like 1, 2, but let's say it's 1, 2. Let me move that so that it actually looks like 1, 2. Does it look more like 1, 2? All right, 1, 2, and I'd like to move this one by, 0.5 radian or something. So here is a segment, and you rotate it by whatever the angle is, theta radian. And you can see that there must be that point, and the question is that what is that point, right, the x comma y? Can we calculate that point? Theta degree 1, 2. What is the formula for that one, right? So that answer is written down there. Okay? But let me explain a little bit about this linearity so that you understand ingredients of this 4 number a little bit better. Linearity says that, all right, if you want to solve this general problem, I have arbitrary point, rotated by theta around the center. What is the coordinate? And linearity says you don't have to look at the general point. All you have to look at is where 1, 0 is going, which is here, and 0, 1 is going. This choice of 2 points is not, there's nothing particular. You can use other points, but it involves zeros, make computation a lot simpler and easier. So here's my first challenge to you, that the circle around it here is a unicircle. That's not the part of the challenge. Now first, I'm rotating this one by angle S, radian, theta radian. So here's a theta radian. Make sense? So this general problem applies to the specific situation, 1, 0. Do you know what this x coordinate and y coordinate is? That's your challenge. If I apply this rotation idea to the 1, 0, do you know the answer to the x coordinate and y coordinate? Of course, it's a trigonometric answer. What is the x coordinate? X coordinate of the unicircle is cosine theta. Remember that part? And that theta is exactly the angle of that point in standard position, which is theta is described in standard position, correct? Y coordinate? Sine theta. Easy. So we know if you rotate by one theta degree, you know what happened to 1 comma 0. It goes to cosine theta and sine theta, right? Okay, that filled up this first column. Because in the matrix algebra, they don't want to use this 1 comma 2 like horizontally like this. They want to use column vector. And it is more natural with the matrix multiplication. And I'll show you how this matrix multiplication works. All I'm doing in here to help you remember, understand this formula, this matrix is a little bit better, right? You can just memorize it. I'm explain a little bit more. So what is the second point they wanted to rotate is 0 comma 1, right? This is the hard part. If your 0 comma 1 is rotated by theta, this theta angle in here is not in standard position, right? That's why it's challenging. So what is this point right there? I start from 0 comma 1, rotate by theta, and what is this guy? That seems like a challenging problem. But if you really look at it carefully, if you go theta degree, and from 90 degree to the theta degree, you can easily figure out this angle here being 90 degree there, right? That's not too hard to figure out. So what is the relationship between this line and that line? They are perpendicular to each other, right? Do you remember the relationship between the slopes of the two lines that are perpendicular to each other? Right, negative reciprocal. So the slope of this one, the sine theta divided by 10 cosine theta. Remember that part? Y coordinate divided by x coordinate. That's the slope. Negative reciprocal and being on the unit circle and knowing the rotation and all that, turns out reciprocal flips these two things. So here, not cosine theta, sine theta. Sine theta goes up there. Cosine theta goes there. Reciprocal slope makes this one flipped. And negative part, negative should go somewhere because of the orientation. If you look at case by case, it turns out negative should go to the x coordinate. So x coordinate of that point is a negative sine theta. Y coordinate of that point turns out to be cosine theta. That fill in the second column. That's where these numbers come from. 1 comma 0 after rotation theta goes there. 0 comma 1 goes to this point. What is the relationship between these two coordinates? Negative reciprocal, right? Flip around and put the negative somewhere. That's how they got this 4 numbers. All right, that is called a rotation matrix. So what do we do with these 4 numbers to actually calculate general rotation problem is the following. All right, so we got that matrix. So what happened to the 1 comma 2 is the following. Rotation by theta. 1 comma 2 is there. You rotate by theta there. And what is the answer? What is the x coordinate? Y coordinate is going like this. You write down that rotation matrix here, exactly the same thing. And you write 1 comma 2 like this. And you multiply these two, and that's their answer. The way these things are multiplied is weird, but this is the matrix. Cosine theta and sine theta, that's the rotation coordinate, first coordinate. If you start from 0 comma 1, that's a negative sine theta and cosine theta. And there's a space here. This is not cosine minus sine. These are 4 different placeholder and different slots, so that's the matrix. And we're multiplying 1 and 2. And how do you actually multiply these two? You write 1 and 2 up there, and you multiply 1 down there and 2 down there like that, and they add them together. So this is kind of weird. So 1 is multiplied to cosine theta, and 2 is multiplied to the sine theta, like that. And you add this 2 quantity after multiply, you add it. So this whole thing is a 1 number. Here there are 2 numbers. As you multiply these position, you multiply 1 number. So here's a 1 times the sine theta. The same 1 is multiplied down there. And there's a 2 times the cosine theta. So that's also 1 number. That's the x coordinate of that point. That's the y coordinate of that point. That's their answer. And these are 4 numbers are always there, whatever you coordinated here. And if you multiply in this fashion, that'll tell you what the coordinate is. So that is called rotation matrix there. All right? So I will use this rotation matrix to answer our original problem. How is this relationship between the trigonometry of a sum of angles, difference of angles? Okay? So here it is. Our original problem again. Y coordinate, X coordinate, and here is a giant unit circle. 1, 0. So the problem is the following. Angle S and angle T and angle S plus T, right? Let's focus on that one. So I'm going to sketch angle S first. So this is one here. S radian, you go there. And what is this point here? Anybody remember the x coordinate of that point? Cosine of S. Excellent. And sine of S. All right. Then what do we do more about in terms of you go S and T more, right? That's what we're going to do. So this is the location angle S. If you go T more radian, and there is this point. So let me ask you this question. In standard position, what is the angle of that point? Answer is not T radian, right? What is that angle there? S plus T, standard position, go all the way from here. Angle associated with that point in standard position is S plus T, not T, right? So let's do the same thing. Oh, if it is S plus T, I can write down what is the X coordinate or what is the Y coordinate. Cosine of S plus T. Excellent. Right there. And here's the sine of S plus T. If there's a different way of calculating that point, and if you equate that with this one, and that'll be the formula. And what is a different method? Apply rotation matrix. So do we need to apply rotation matrix, go from here to there? It looks pretty much already in terms of S and T, so we're not going to do that. We're going to apply it here to there. That's where we're going to apply rotation matrix. All right? So the point we're applying is this one, and multiply by rotation matrix. So anybody remember the rotation matrix, how it looked like? What is the first column there? It's a cosine of some angle and sine of angle of the angle you're actually rotating from that point you're applying. So how many angle are we rotating further? T, right? We're not using the standard position angle. We're going from here, T more radian. So that's why you're putting a T in there and T in there. And we flip this one because of the negative reciprocal business, right? But it's only reciprocal. Where's the negative? It goes to the first coordinate. There are 4 numbers separated like this. And we multiply by what coordinate? That coordinate. Then it arrives at here. So what is that coordinate here? Cosine S. That's x coordinate. And sine S. So if you multiply out, and that's going to equal the top part will equal the whole thing, cosine S plus T. Bottom part is going to equal the sine S plus T. So this number is written up there. And multiply through down, and then also add it horizontally. So this whole thing, again, you're going to see a long expression, but that's one single number, coordinate, x coordinate. So cosine S and cosine T multiplied. You see that? Cosine S. How about this one? Minus sine S sine T multiplied. That whole thing is one number. That's the x coordinate. That x coordinate must be equal that x coordinate up there. Correct? How about down here? Cosine S multiplied to the sine T. That one multiplied to the cosine T. Sine S cosine T. That whole thing must equal the y coordinate there, right? So that is addition formula. That's how cosine S plus T unfolds. So let me write this one down so you can see it together. Here, if you compare the two x coordinate, we conclude cosine of S plus T is always equal to cosine S cosine T minus sine S sine T. That is called the addition formula of cosine. If you compare the two y coordinates, you arrive sine s plus t equals that whole thing, right? But they usually write this one first. You know, 3 plus 5 is equal to 5 plus 3. So we follow their convention that you write sine s cosine t first plus cosine s sine t later. These are called addition formula of cosine, addition formula of sine. And this is what I want you to memorize. But here's one thing. One way to remember and memorize this formula is that cosine is always in the product